Hello, welcome to the third lecture of this series of water treatment. In the earlier session, we have seen that how lime and soda is added to treat the water for softening, and after addition of lime and soda, calcium carbonate and magnesium hydroxide is formed, and that is separated as sludge. So in the big tank, cold lime and soda process can be carried out, and it is carried out at room temperature. Now we will see the another type of process, that is hot lime soda process. In the cold lime soda process, the residual hardness in water is around 50 to 60 ppm. And hot lime soda process is comparatively efficient because a stream of water is sent inside the chamber where lime soda process is carried out. Therefore, the total residual hardness in case of hot lime soda process is in the range of around 15 to 30 ppm. So this is for cold and this is for hot. The residual hardness in hot lime soda process is better. The outcome is better. In cold lime soda process, the coagulants are required. Whereas in hot lime soda process, coagulants are not required. Because the accumulation or growth of particle takes place at high temperature, the velocity of water is good in the hot lime soda process because the temperature has the effect to increase the velocity. The fundamental difference or the success of hot lime soda process is that much of the precipitation occurs in 10 minutes only if the temperature is up to 90 to 100 degrees centigrade. If temperature is raised to the range of 90 to 100 degrees centigrade, then you will see that precipitation occurs only in 10 minutes. Whereas if the temperature is in the range of 10 to 15 degrees centigrade, it takes more than 2 hours to precipitate the sludge. Therefore, completion of reaction is fast in hot lime soda process. We will see a schematic of the hot lime soda process. Here you can see in the diagram that the similar tank as you saw in the cold lime soda process, exactly similar tank is there designed. It is rested on the pillars and the raw water is fed from top. On the side, in a side arm, superheated steam inlet is there. So the steam is provided from one side. This steam raises the temperature of water. On the another side, chemicals are added, that is lime and soda. So this is a feed inlet for lime and soda, and coagulants are not added. They are not required. A triangular shape is there, a conical shape is there. So the funnel like shape inside helps the water to go through a funnel and then it moves outward. the whole reaction takes place in the upper part, and that reaction takes place at higher rate because of the temperature of water. At higher temperature, rate of reaction increases, and the two parts are there which are to be considered. One is reaction to convert the hardness into calcium carbonate and magnesium hydroxide. That is one aspect, formation of these two species. And second is the growth of the particles in size, growth significant in size so as to come down with gravity. That is another aspect, and that decides the precipitation, rate of precipitation. How much quickly the products formed will come down with gravity. That is also important. So completion of reaction and the particle size growth, these two aspects are there, and both of the aspects increases in rate, the rate of formation of products and the rate of formation of particle size both increases in hot lime soda process. Once the water comes down, the precipitated calcium carbonate and magnesium hydroxide sludge, this comes down, this can be taken out by opening the bottom wall so that all the sludge comes down. The water that is filtered or water that is softened, that comes to another tank. You can see a side tank is there. This side tank has some beds for filter. The first one is fine sand layer, the second is coarse sand layer, the particle size is bigger, like just less than pebbles, you can see. Then gravels are there, the biggest size one, and thus filtered water comes out from the final outlet, filtered softened water outlet. Whatever particles those could not grow in size and form the part of this sludge, they will come along with water in the side tank. And to filter such particles which could not grow in size and which came up with the turbulence of water, those particles are trapped in the bed that is provided here. So the role of this bed is to filter whatever could not be settled down due to gravity in the first chamber. So this is about the hot lime soda process. This is a simple schematic diagram of hot lime soda process. The advantage of process over the cold lime soda is definitely there, and thus the hot lime soda process is preferred over cold lime soda process. But one should remember that both hot and cold lime soda processes do not give the water of zero hardness. In fact, lime soda plants do not produce water of zero hardness. What maximum can be achieved is that the raw water which is filtered and having significant hardness can be treated with lime and soda to reduce the hardness up to 90%, 95%. Say the hardness of water, if it is in the range of 300 to 500 ppm, can be brought down to 50 ppm. This can be achieved, and this is in fact achieved in the hot lime soda process and cold lime soda process. But hot lime soda process is better, it is advantageous, the rate of reaction is fast, coagulants are not required, particle size growth takes place quickly because of the elevated temperature, the formation of products, calcium carbonate and magnesium hydroxide, that also occurs quickly, and therefore hot lime soda process is preferred over cold lime soda process. So we will stop here and we will see the next process of treatment of water for softening in the next lecture. Thank you.